Wait, wrong one. Okay, let's check it out. Hmm. Okay, both get and put has to be O1. So both put and get influence recently used or not, like the two in front maybe, and so this look like we can do double linked list for uh, O1 removal, and the get key here we need in order for us to do O1, we have to have a hash map, right? So let's do that. For this double linked list, right? We have the value so dot value, right? This will be also value. So first let's okay, so also need to so we would call this cache, right? Equal DLL capacity. Right, so this is simply return the value of the key if it exists, otherwise return negative. So we also need to so this here will probably have a so head and tail as capacity. Or maybe let's just move the tracking here. Let's just call this a node. This will have none, right? Okay, so dot capacity for capacity and cell dot size 0, right? So when we put, we gotta say, okay, we also need to check so that if you want to get in O1, right? That means we have to quickly figure out what node it is, right? Given the key. Okay, let's call this key checker. It's gonna be a dictionary. So here we just return cell if key not in cell dot key tracker else cell dot key tracker dot key. Right, so that is solving the gap. Okay, so we need to evict the list recently used. Okay, so first, if when we get this, right, we probably also have to move it to the front, right? Because when we get it, that means it's the most recently used, right? So okay, so if key not in cell dot key tracker, then we have to return -1. Otherwise we have the node value, right? Actually, let's just do value gonna be cell dot key okay, so key gonna be equal cell dot key tracker with the key, right? So return v here. V gonna be key dot value. Actually, we could just do return key dot value, right? So now we have to update, move the key to the front, right? Right. So do we even care about this head and tail? Probably not, right? So now if k.prep and k.prep.next equal to, we still need to know where the front of the node is, right? Okay, so now, do we? Hold on. So when we put here, the least recently used is basically the node in the tail, right? Okay. So we still need them. Okay. So dot head equal none. So dot tail none. Right. So first we gotta do is move the previous, basically connect previous to next, right? K dot prep, then go K dot next, right? K dot next, then K dot next dot prep, K dot next dot prep equal K dot prep, right? So and then move is to the front of the list, right? So now move the front of the list, right? So if so cell, the outcome of this is the head gonna become cell.k, right? So if right, okay, so now we have that the head that we want to, okay, so basically if cell dot head we have the head here, so basically cell dot k dot next now gonna be from cell dot head, right? Cell dot head dot next, so cell dot k dot next gonna point to the head, and cell dot head dot previous gonna point to cell dot k, right? So cell dot k dot previous gonna be equal to none. Oh no, not cell, k, sorry. So k next now point to the head, k pref none, and then oh, this one is cell is fine, right? And then finally, right, think so. So we fix the connection between K and the previous. If there's the previous, then we point the previous next to the next one. If there's the next one, then we tell the next one previous to be previous. So now we can set the next to point to the head, and the head previous is gonna be, oh wait, hold on, yeah, okay, and then K now become okay, yes, I think this should be it. Okay, so put if the size is okay, so first we gotta check if the key exists, right? Set the value of the key if the key exists. So does that mean we check the value? Okay, if key is in cell.key tracker, then cell.key tracker up key dot value equal to value, and then return. Otherwise the key, if the size is not the size is less than cell dot capacity, then we add the key. Do we just add it to the left? And also so let's write a function for else, then we return, right? At the node, here's evict the list recently used, which is basically the tail, right? So they guarantee the capacity is always greater than, yeah, it had to be at least one, right? So basically cell dot tell previous, and cell dot tell dot previous dot next equal to cell dot the previous. Basically we just need to fix the tail, right? If there's previous, then we tell the previous next, gonna point to cell dot cell dot next, right? Right, and then if there's the next, hello Kiwu, what's up? And okay, so basically the tails always have the last one, so we do, didn't we just basically do tail dot tail we basically can just do tail dot tail dot period dot next equal none, right? And cell dot tail equals cell dot tail previous, right? So tail dot previous dot next to that, right? And we also have to delete the key in the tail dot right. Key tracker, cell dot key tracker maybe we should also register the key here. Right. So tail dot key. Right. So when we add the node, we do this. So node. Okay, so when we add the node, basically we add it to the front so that we don't always have to fix the tail, right? So if not cell head, then cell dot head equals cell dot tail equal, what do we do here? Key value. We call this node key value, and then we also have to track key tracker equal to cell dot head. So basically we do node equal actually this way. So okay. Otherwise we do node dot next equals cell dot head dot previous equal to node, right? And then we have to fix the head equal to node. So this point to the head point back, and then finally the head has to do that, right? Okay, and then you return. Then if the capacity is over the capacity, then we basically just pop the tail. Right, I think, let me see. I don't know. What? I don't know. I don't know. Okay. I'm still doing this, and why do you pop up? I don't know. I'm intimidated. Don't give me question why I'm solving level 1 so far. Okay, what happened here? Oh. Oh wait, hold on. We forgot to increment the size. So when we added in cell, okay. What do we do here? We got a none here. So let's do a debug function to print out some stuff, right? Debug. So equals cell.head yb then cell dot p. Equal right. P dot next. Right, so this time we call the put. We print so far out less than capacity, then we do let's do some debug. Oh, we cannot do this. Should be able to. Less than capacity. Oh, let's just do this. Out of capacity. What is it? David J24. So we got 1122, good. Out of capacity. So this is, let's just call code. Three. So less than capacity, then let's just print them at the end. Okay. So now you do when you put 3 out of capacity, you have to take 2 out. Okay. So you can get. Oh, hold on. What happened in get here? Okay. Print. Dot debug. Okay. So 1, 2, good. Okay, so when we move it to the front, okay, so become 1, 2, good. Then we put 3, 3. We think it's out of capacity, so we gotta do so. After evict, so dot debug right here. Okay, so the error is right here. Tell the previous. Okay, if cell the previous, then right, dot tell dot previous. So somehow our tails got hold. Okay, hold on. Node the next is the head. Head the previous point to node. Tail the head to node. What's wrong with the tail head? Tail's none. What is it? We found the node. If the node, okay, here's the thing. It's actually the tail. If the node that we want to get is the tail, right? Then we also have to update them, right? So when we put this, head is tail equal this. Okay. So if the node that we want to take to move to the front is actually the tail, okay. Okay, so first thing is, if k gonna be equal to the tail, then cell.tail gonna be tail.tail.next, right? Does that still make it no though? Cell dot what? Okay, still none, right? So when we get this, and this just so happens to be the tail, okay, and cell dot size, right? We actually equal 1, right? And cell dot cell greater than 1, right? Otherwise the tail gonna be the same. The tail here is none. What's going on? So head tail pointing to this. We put 2, then the tail should be this. Okay, hold on. Let's debug. debug with pointer, pass the p here, and basically okay, so this is actually cell dot debug with pointer, right? We pass the head here and we pull all this implementation to here. Okay. So okay, so when we call get here, we want to know the tail, right? Okay. Here. A lot of people, Twitch is so online right now. Twitch. Gotta be faster. So if we wanna get this, and this basically move it up here, right? So we want the tail to be 2, right? So okay, so the tail actually become previous, right? If k equals cell dot tail, right? And cell dot size greater than 1, and that means cell dot tail gonna be equal to cell dot tail dot previous, right? Right? What the hell? Okay, so first we want to know what happened with after we did this. We go get, we got this, and then we go cell debug tail, right? Let's just do this. Let's be funny. We just call this G-U-B-E-D. Too bad. Let's pat the tail here. See what's up. Too bad. Too bad. So when we call get, this is wrong here, right? So something that we did here is wrong, right? So the key, hold on. When we added here, the key points to node, yeah. So now we do get the key. And we say that if the key equal to tail, and so basically here, the tail right now is this one. Oh wait, This is previous, no? Yeah, that is wrong. Okay, we put less than good. And we put 2 to go up here. And then we get, and we got this tells this. Good. And then when we put 3 out of capacity, we evict the 2. Oh, when we evict, when do we decrease the size? Key is in. Oh, we can change the value here. Oh, I see. So let's just find the node first. Node. Key tracker. Okay. Then we have to change the value. Gonna be we don't have to change the from here, right? Because that is one fix. Right, so return 1 is correct here. -1 good. And then put evict key 1 caches or evict key 1. So now, something is wrong here. So out of capacity. So okay, after we evict, we have to add this, right? So let's roll the function add node, right? Because we want to reuse this thing. So basically, let's roll the function for add node, and we want this. Right. So if size is less than, then we want add node. And after evict, then we also add node. And after add node, okay. So we add capacity, then we fix the tail, then we do tail dot size minus 1, right? Okay, I think that should be it. Let's see if we got it. Any still output? What? Oh. Let's do some print stuff. What? Okay, submit. Wrong. Something wrong here. Let's turn on the debug. Okay, capacity is what? Description 2. Okay, so let me write them down in my notes. Pen and paper time. So what do we do? Put 2 1. Okay. Put 1 1. Go in front. Hold on. We wanna also add a debugger. Add node. So 1 1 good. Put 2 3. Why is it not out of capacity? We type them wrong. Capacity if the number of views exceeds the capacity from this operation. So it's basically the capacity is actually if the size equal capacity, then that is when you evict, right? Which is what it is, right? Okay, last time quickly. Put on one, okay. Oh, when we put 2, 3. Oh, we changed the value of 2 to 3. Good. When you change the value to 3, right? Do you also have to do this? This moving stuff here. And let's say you do. Right. So you change 2 to 3 and you move 2, 3 to the front of 1, 1. And then you put 4, 1. Okay, when you put 4, 1, so you want to delete this. So 2, 3 become 4, 1 here. Right. So we want to get 1. Return negative 1. Good. And we want to get 2. Right now, our code return negative 1. Does that mean we evict the wrong one? Right? We had that. We had that. Good. We put 2, 3. So hold on. Let's say we don't have to move it to the front input. What happened here? So you put 2, 1. Put 1, 1. Right. And you put 2, 3. Simply replace them. Put 4, 1. This is when it out of capacity. 3, 4, 1 here. The fact we evict, we also have to do the move to front thing. So every time we add 1, we have to move them to the front. Okay. We add 1, we gotta do. We did add it to the front, but the case is when we do this, we also have to move them to the front. The key in this, and you have to do the same logic here. Let's write the function to that, right? Okay. Move the node to front. Shell node. So basically, do the same logic here. Instead of that, do node next. This node. Right. So basically after this we do cell dot move node to front. Okay. Right. So this should just work with the current thing because we just refactor one. Right. So now next thing we gotta do here is got a node, change the node, and we just move node to front. Okay, which is node. Going on. Look. Node.next equals set ahead. Something is wrong. So we get a node that's next to the head point back, and then node previous to none, then head point to the node. Wait, do we see the same, the value differently? Something makes this stuff stuck.
You have longed for the castle in the heavens, paving your way there by annihilating corpses. That is you.
Key in key tracker.
Pile them up.
Then get the node.
All you have left. All you need to do is chant the phrase, I sacrifice, and you shall be granted raven black wings.
Something infinite loop. Okay, so let's write them down and see where did we do wrong. Infinite loop with open tester, case 2. So got 2 capacity.
I sacrifice.
So you put 2 1, okay. It does key in key tracker now. And we add the node. 2 1. Good. Put 1 1 to front. Last week, yeah. And then we put 2 3, which is we go here. Oh, 2 3, right? So we get this. Just say the value now. Gonna be 3. Right? We invoke the function to the front. right? We say that this is the head right here. Node next point to, so this next here point to the head, and the head
Of the thousands of comrades and the tens of thousands of enemies, you're the
head the
only
previous point to this.
one who made me forget
So
my
basically
dream.
head the previous point to this one. This one point to now, and this one point to this. Oh, what about the head dot neck? This is infinite loop right here,
I sacrifice.
right? Head dot neck has to go to. Right, so whatever we have, the notice, the first thing we did is when we change the thing, we have to do the same thing here. We have to tell the previous point to this, and the next point back, right? Okay, so basically what we want to do is derive a function, okay, remove node, right? Node. The first thing we gotta do is
If you touch me, I'll never be never again with you.
so basically this entire logic is needed, right? Is node right. So basically we do self.remove node, unlink, basically unlink, and self.move node to front, right? So this should just work right now with this. Okay, it's not defined. What's the same logic? What? Oh. Sorry. Okay, you can remove all this. So basically we have to do the same thing here. Yeah, so that should fix that. We remove all the print. Just the print stuff. Okay, submit. Whoa. We did something wrong. What is this? Okay, so let's test this out. Okay. So get. Let's do some. Printing.
I just wanted to say
Let's just self.debug here as well. This is the case where update existing key. And okay, so let's do it with them. So okay, put capacity is 1. Okay, so always everything, right? So we do 12.1. Less than capacity equal. What case is telling here? Oh, get. Where's my get? Put 12.1. What happened to get here? Get, put, oh. Okay, 6A, nothing. Put 12.1, good. Get to nothing. Put 15, 11. Oh, something wrong here. So it will be 1511. So in the case that we always evict, we did not handle that. Let me get some water. Okay. So let's try through the logic here. Out of capacity here. Oh, if the size is 1, you have to handle that. Okay. So when we remove node, so when we have get here, right? When they call get to or whatever, right? It doesn't hit that. The key not in 6, 8, 12, okay, get to fine. But when we put 15, this is where we having issue, right? Okay. See, after we evict, then we still have a pointer to this. This is where it's get wrong, right? So something we did here is wrong. So when we first, it has this, right? We delete the key, we decrease the size, we point cell back to the previous one. So this is the tricky case, right? When it's always evicting, you need to handle that. Okay. So this is nothing but evict the tail, right? We add node. Okay, so now the problem here is that, right? So if cell dot size at capacity, right? If cell dot size capacity gonna be equal to 1, then basically cell dot head equals cell dot cell equal to just gonna be add node, right? So basically we have the previous, then we do this, and regardless we do this. Oh no, do this. After add node, after evict. Okay. So basically we have to evict, but if the size actually 1, then we just need to add node, right? And when we add node, we actually fix the head here. So we can do shell dot size equal to 0, right? Then we do this. We fix that. So that means we just need to decrease the size here. And then this will make the size correct, right? And also the side effect is add that. Oh, actually both of them will be adding anyway. Yeah, like that. Maybe it will work now. Or do we have infinite loop? The infinite loop, what the fuck? Okay. What the hell? So we out of complexity with this type of 1. We do this. And we add the node. We bootstrap them here. And we increase them size. Okay, what's going on here? Why do we have infinite loop? Case 3, that is wrong, right? So hopefully, does the other 2 case work? Oh, so if we can fix this issue, we should be fine, right? Okay, let's trade them back with the papers. What is going on here? Okay, we have okay 1 1. Put 1 1, good. Put 2 2. Run. Right. Okay. Good. And then we go get 1. We go get do we now oh this also need to do maybe, right? What? The number here is wrong. We need to evict. When we evict, we do that, then we add the node, right? What the hell is wrong here? only thing is we probably gonna have to trace back the debug line here and see what is wrong. Okay. So when we get 1, we also have to move in the front, right? Yeah, let's just do some debug here. Debug. And what the hell is wrong here? Come on. What's going on? What? Okay, so do some debug. If the tail has something, then we do that. Okay, so why does it suddenly infinite loop? Do I want to play some game or do I want to keep debugging this? Okay. So does debug function, right? If I do this, the debug function is wrong, right? Or somehow the next pointer point back to the front, and this is wrong, right? So it's psi equals 0. When we add a node, right, we have next and thread is none, right? We say that if that is the case, then both the head and the tail are gonna be node, right? Otherwise, we add it to the front, right? So node next will tell the head, and the front of the list point back to node. And now move the head to the point to that, right? So then, regardless, we track the key to that, right? So how we add the node, right? So now when we put if we found the key, we basically get that node out, fix the value, and move it to the front, right? So when we remove node, the special K of 1 might be crazy. Okay. So if the psi is 1, right? I don't even know what's wrong here. tree. Let me think for a moment. There gotta be a good way to write this. Otherwise, it's easy to make mistakes. Other note here. Okay. So we have a double linked list. And when we call get for specific value, we have to remove it out and move it to the front, right? The two operations that we did is unlink the node, right? So what happened when the node that we unlink is the head and the tail, right? So that case we need to be careful, right? So let's say the case that we unlink the tail, right? So when we unlink the tail, let's first do unlink the head, right? If we get the most recent node, right, nothing have to do, right? Nothing should happen, right? Because that was the most recent node. Position stay the same. Now the situation will be different if we unlink the tail, right? We unlink the tail, we remove it, which is what this function does, right? Remove node. It check for the KO. For the K, if it is equal to 1, if the size equal to 1, what happened? Right? So that means if the list has one size, right? This will be wrong, right? So if we tell size greater than 1, good. Otherwise, we ask if it have no up here, right? But if the size is greater than 0, greater than 1, then this point to this, then the tail gonna point to this, right? Which is good. Move node to front, good. Yeah. Move node to front is basically link them together, okay? But what happened when get has the size of 1? Okay. So now right, head and tail point both point to here. Right. So remove node is basically empty here, right? Move this node. Move node to the front. no. Okay, it does equal tail, but right. No to fun. Oh, this is when it is infinite loop right here, right? So for the case that it is one node, right? So basically what we did is if the size is basically, we can move to the front if cell.size greater than 1, we can do this. Otherwise we would be in infinite loop mode, right? What? Right, because now we're saying if we go get the tail, suddenly tail.next equal to itself, right? There we go. Let's debug now and see. Why do we have infinite loop here? We get infinite loop, guys. I'm thinking about playing games now. We'll have to come back to this tomorrow morning and see.